In this video, I'm going to apply integration by parts to solve this beautiful integral. And the answer to this integral is shown on your right hand side. So integration by parts, what I can do is to do the DI, which is the shortcut to the integration by parts. I am going to differentiate the whole integrand, which is the sine hyperbolic inverse of x, all this one squared, and I'm going to just integrate 1 dx. So this is plus, next one is minus. When I'm differentiating the sine hyperbolic inverse of x, I can do that here real quick. Sine hyperbolic inverse of x squared, I have to differentiate the power using the power rule. So I have 2 times the sine hyperbolic inverse of x, and now we have to differentiate the sine hyperbolic inverse of x and multiply. That is 1 over the square root of 1 plus x squared. The derivative of the sine hyperbolic inverse of x is 1 over the square root of 1 plus x squared. So differentiating this one is 2 times the sine hyperbolic inverse of x. This one is divided by the square root of 1 plus x squared. And now integrating 1 in the x world is just x. So let me clean this one, and then we have space to write the resulting value of our integral. So what we do is to take the product of diagonal terms. We are done with the integration when we do that. Then when we multiply terms horizontally, we have to take the integral. I is going to be equal to multiplying terms diagonally. That is going to be x multiplied by the sine hyperbolic inverse of x, all this one squared. You see that we have gotten the first term of our answer, and now we have minus the integral because we are multiplying terms horizontally. That is going to be 2 times x sine hyperbolic inverse of x. This one is divided by the square root of 1 plus x squared dx. So this is what we have. And now for this second one, I'm going to apply integration by parts again for the second one. Let me call this one I1. Why not? So I1 here is equals to the integral of 2x sine hyperbolic inverse of x. This is divided by the square root of 1 plus x squared dx. Cool. So here we are now going to apply the second integration by parts. Let's go again. D for differentiation, I for integration. Here what I'm going to differentiate is the sine hyperbolic inverse of x. This is plus, next is minus. And what I'm going to integrate is 2x divided by the square root of 1 plus x squared dx. Differentiating the sine hyperbolic inverse of x is 1 over the square root of 1 plus x squared. This is what we have. What about integrating this? Let me do that here real quick. So if I are integrating 2x dx over the square root of 1 plus x squared, this is what we get. Let's do a u sub. You can let u to be equal to 1 plus x squared. That means that du here is going to be equal to 2x dx. So this integral 2x dx is replaced with du on top divided by the square root of u. And this is equals to the integral of u raised to the power negative 1/2 du. So integrating u to the power negative 1/2, we have u to the power negative 1/2 plus 1 over negative 1/2 plus 1. And this is equals to u raised to the power half all over 1/2. And this is equal to 2 times the square root of u, because 1 over 1/2 is 2, u raised to the power 1/2 is the square root of u. So we just replace u, which is 1 plus x squared. So this is equals to 2 times the square root of 1 plus x squared. So it means integrating this, we are getting this. So let me write that here, and then we apply the integration by parts for the second time for I1. Alright, so let me rub here, clean this one for free up space. Alright, so now multiplying diagonal terms. This is the drill. When we multiply terms horizontally, we have to take the integral. Alright, so I1 here is equal to, okay, so 2 times the sine hyperbolic inverse of x. This is multiplied by the square root of 1 plus x squared. And now minus the integral, because we are multiplying terms horizontally, that is going to be the integral of 2 times the square root of 1 plus x squared. This is multiplied by 1 over the square root of 1 plus x squared dx. So I1 here is equal to 2 times the sine hyperbolic inverse of x times the square root of 1 plus x squared minus the integral of 2 dx, because these ones will cancel out beautifully. So integrating 2 in the x world is 2x. So this is the sine hyperbolic inverse of x multiplied by the square root of 1 plus x squared minus 2x. So this is integral I1. So we can go back to I and now replace what I1 is. So I is equal to x times the sine hyperbolic inverse of x, this one squared, minus I1. Minus I1. This is what we have. So minus I1 here. So minus I1, then we can plug in I1. So minus I1, and I1 is 2 times the sine hyperbolic inverse of x times the square root of 1 plus x squared minus 2x. We are done. We put the constant of integration c. I is equal to x times the sine hyperbolic inverse of x, this one squared. Now open with the negative, we have 2 times the sine hyperbolic inverse of x times the square root of 1 plus x squared plus 2x plus the constant of integration. And this one agrees with the answer that MIT gave, and that conforms with the answer I gave in the beginning of the video. So this one is the answer to this beautiful integral. If you find that helpful, please give me a thumbs up and subscribe to Calculus Diaries for more content on integrals. I thank you so much for watching, and I will catch you up in the next one. Bye bye.